So hello friends, I welcome you all to my channel. So in this third video, we will look into more concepts of free fall again, and motion under the influence of gravity only, where the only force acting is gravitational motion. Let's just say that you are throwing a ball upward with the speed of u. Okay, you are throwing a ball up with the speed of u. It travels a distance upwards, and at the end of its motion, at the topmost point of its motion, its velocity is equal to 0. So it is coming to rest here, isn't it? It is coming to a rest over here, right? Acceleration to gravity is acting in the downward direction. So therefore I can say it goes till this point. Let us say s distance have been covered by it, and at the topmost point it covers s distance and it comes to a rest at the topmost point. What is the time taken to reach over there? V is equal to u plus u minus of gt. So therefore this is equal to 0. Time taken to reach the topmost point is u by g. Remember this, whenever you throw a ball upwards, whenever you throw any particle upwards, the time taken by the body to reach the topmost point is u by g. It is dependent only on the velocity and acceleration due to gravity. So this time taken is u by g. Okay, see, imagine that I am filming this in a camera. Okay, I take a camera, I take my DSLR and keep it on. I start recording it. I throw a ball upwards, it goes all the way up and it stops over there and it starts coming down. So I am just taking that particular part of the video where the ball is going upwards, and I am projecting it on a screen. Okay, I connect it to a TV and I'm seeing that, okay, the ball is going upwards. So yes, I am throwing it, it goes all the way up, it comes to a halt in the topmost point. Imagine that I am actually replaying this in the reverse direction. If I am just rewinding it, what will you see here? I will see that if I start rewinding this, here the velocity is the initial velocity, which is 0, and as it comes down the velocity is increasing, and here when it reaches over here the velocity will become u itself, right? When I replay it, this is the initial part and this is the final velocity. Initial velocity is u is equal to 0, final velocity is u itself, and what is the time taken to reach down? It is u by g. Just replay, just rewinding everything, right? And it covers the same as distance to reach the downward part. What actually happens when it comes down after rest here? What actually happens when it comes down? It goes all the way up, it stops over here and it comes down, isn't it? When it comes down, exactly the same thing is going to happen. Here initial velocity is 0 and then it comes down, and here when it hits the ground the velocity is u itself in the downward direction. That's the point. So the upward motion and downward motion are just rewinding of the same thing. They are exactly the same. And when will it reach here? Again time is equal to u by g. So after again u by g, it reaches over down, right? So the total time of flight, the total time taken by this ball to go up and come down is 2u by g. So I can write time of flight is u by g plus u by g is equal to 2u by g. So this is one of the most interesting feature over here. So if it covers s distance upwards, it also covers the same s distance down. So the distance traveled is 2s. Displacement is 0 because initial position and final position are the same, right? So this is the basic concept that you are supposed to know, so far as to go into a derivation that I am taking you towards, which will help us get a formula which is utilizable in all the many kind of questions that you are going to see in this particular video. So let's go to that particular derivation now. So take a look at this question now, guys. The particle is thrown upwards from the top of a tower of height 60 meters. So they have given height h is equal to 60 meters and you are throwing this ball up with a velocity 20 meters per second. Or I can just take a general case here. We will try to get a formula for this and then we will substitute the values u. Okay, and tell me the total time of flight of the body. Total time of flight. Can we derive an expression for this so that we can study that and we can use it whenever it is possible in questions that they ask from this chapter? Now tell me what is the time taken to reach this topmost point. If I am throwing it with a velocity u, it will reach the topmost point at time t is equal to u by g. Okay, I hope you are convinced when I write time t is equal to u by g. We have been doing this in many questions. Even in the first video we have tried to use this equation. So what is the distance traveled from the top of the tower to the topmost point? Distance traveled from here, that is the top of tower, to the topmost point is ut minus half gt square. I am considering the sign conventions here. minus half gt square. So let me substitute the value of u here, I mean time as u by g. So u into u by g is u square by g minus half g multiplied by t square is u square upon g square. Fine. So what I will be getting after this is something like u square by g minus of half, or I can say u square divided by 2g. So this is the height which is covered by the body which is going upwards, isn't it? Yes, yes it is. So this much height is u square by g minus u square by 2g. When it comes down, now talking about the descent of its motion, right? If I talk about its descent, what happens is, first it has to cover this much distance. When it reaches over this much distance, then its velocity is u itself in the downward direction. And then it has to cover this much h meters also to reach the ground. Okay. So how much is this distance? This much distance is u square by g minus u square by 2g. It's symmetrical. The same distance it has to cover in the downward direction also. Distance, I mean vertical distance, right? Not the horizontal distance. Horizontal distance is actually, it is going in this way. So this much is the horizontal displacement which is covered by the body from the initial and final position. But here we are talking about the vertical displacement. So this is, I mean vertical distance. So this much is the distance it has to cover so as to reach the same level as that of the tower. Then again it has to cover an h meters to reach the ground. So the total distance covered by the body is u square by g minus of u square upon 2g plus h to reach the ground, right? Let me put this equal to, what is the velocity here? Yes, okay, here the velocity at the topmost point, the velocity is equal to 0. So this is my initial velocity when it travels the descent of its motion. When it travels the descent of its motion, my initial velocity is 0 and final velocity will be something which is greater than u. When it reaches over here, it will be more than u, because here the velocity is u, and as it comes down it accelerates again, and here the velocity will be something which is much higher. Initial velocity, I am just talking about its descent. I am just talking about the descent. Where is the descent happening from? This is the point from which the descent is starting. From here it descends towards this position. I am considering only the descent. So this is the total distance to be covered is equal to ut plus half at square, half gt square plus half gt square. Gravity in the downward direction is positive. Now what is the velocity value? What is the value of initial velocity? 0. So it is half g t square. Okay. Now what am I going to do? I will just place my t over here, t square, rest everything I am going to take it over there. So 2 u square by g square minus 2 and 2 will get cancelled off, u square divided by g square plus 2h by g, this is equal to t square, right? So how much is this? This is 2u square by g square minus u square by g square is u square by g square. So from here I am going to get an equation like t is equal to root of u square divided by g square plus of 2h by g. Okay, so this is my first equation that I am going to get from this. Now tell me, what is the total time of flight of this body? The time taken to cover the entire distance from the topmost point to the down, time of descent is this much. But there is a time of ascent also, time to reach the topmost point. This should also be considered. So along with this, I have to add this u by g to get the total time of flight. So the total time of flight, let me write it as capital T, is equal to, if I write over there, I'm not sure if you will be able to get everything in the best way possible. My image will be obscuring your view. So the time of flight t is equal to how much? The time taken by the body to go from the top of the tower to the topmost point, that is u by g plus whatever is the time taken to descend down, that is equal to root of u square by g square plus 2h upon g. Right? So this is the question. This is the answer for your question. U by g plus root of u square by g square plus 2h by g. I will suggest you to remember this. Okay, by heart this. How it is very easy to by heart, isn't it? U by g, time taken to go up, and then root of square of that, u square by g square plus 2h by g. U by g plus root of u square by g square plus 2h by g. Remember, this is the time of ascent, this is the time of descent. The first part is the time of ascent and time of descent. Okay, remember this. Whenever you are throwing a ball from a height h upward, it goes up, it comes down. What is the total time of flight? Total time of flight is equal to u by g plus root of u square by g square plus of 2h by g. Right? I will suggest you to remember this because this is a very useful formula. So far as your practice tests are concerned, you get a lot of questions in a practice test, so you can use this kind of an equation wherever it is possible. So I will show you certain examples where you can use this kind of an equation. This is very useful. And whenever you use this, remember this. Sign convention. Okay, I have already used this. So sign convention is already used. Don't get confused whenever I say this. Sign convention has been already used. In the making of this formula. So just by saying that, okay, you are throwing the ball upwards, so the g is negative, never put a negative sign in any of these equations. Never put a negative sign for g in any of the parts of this formula. Never put a negative sign outward, never put a negative sign inwards. I have considered, while making this formula, I have considered the sign conventions. Whenever they say that you are throwing a ball up from a tower, from a height h, just plug in the values here. Don't ever go for any kind of sign convention. I have considered everything while making this formula. Sign convention is not applicable anymore. If you do that, you will land up in trouble. But this is as to get the maximum benefit of this, you need to know where to use this, how to use this without any mistake. So you can simply remember this. Whenever they give you a question, directly substitute the values. Never go for any sign convention, right? So yes, let's go to some other question. But yes, I would still like to highlight it over here. Sign convention has been already used here. So never land up in trouble by using this. Just substitute the values. That's enough to get an answer. This is the total time of flight taken by the body thrown up from a height h that it takes to reach the ground. U by g plus root of u square by g square plus 2h by g. Let us see this question now. From a tower of height h, a particle is thrown vertically upwards with the speed u. The time taken by the particle to hit the ground. Time taken by the particle to hit the ground is your time of flight. So that is u by g plus root of u square divided by g square plus of 2h divided by g. This is under root, isn't it? Under the root, and yes, this is equal to how much? Is n times the time taken by it to reach the topmost point of its trajectory. See, topmost point is this, and the time taken to reach the topmost point is u by g. So this is n times u by g. Now only thing left to do is to do some mathematical juggling to get the answer correct. So let me keep this here and let me take that to the other side and take the root to the other side. So first of all, let me take u by g to the other side. So if I take u by g to the other side, I will be getting n minus 1 u by g. Okay. Now let me take this root to the other side. So this is square, square and square. And you are going to get u square divided by g square plus of 2h divided by g. Now what will I do? I will take this to the other side. Okay, when I take that to the other side, I will be getting 2h divided by g is equal to, how much will this be? N minus 1 whole square minus 1. So this will be n minus 1 the whole square minus 1 u square divided by g square. Okay, so this is the value which is coming in the RHS side. Now what do we do in this kind of a situation? So this is something like 2h by g is equal to, how much is this? N minus 1 the whole square is n square minus 2n plus 1 minus 1. N square minus 2n plus 1, n square minus 2n plus 1 minus 1. So that is n square minus 2n. This is n square minus of 2n u square divided by g square. 1 g will get cancelled off. So this implies I can take n outside, isn't it? This is n u square into n minus 2 If I take this to the other side, is equal to 2gh. Yes, this is my answer. So out of this options here, I get option third as my correct answer. So this is the use of learning this equation that I was just telling you. I was deriving this in front of you. Otherwise, if you get a question like this, we are confused in a way where to start, or we may not know where to start or how to start solving this kind of a question so as to reach an option, reach an answer that is given by them in the question. So yes, that is the importance of this equation specifically for solving questions in. Let's try to use whatever concepts we have learned, that formula which we have learned to solve a question of projectile motion also. See, they are saying that a ball is thrown at an angle of 30 degree to the horizontal. So this is a bit different kind of a question now. So yes, let this be the horizontal. Now it is thrown at an angle of 30 degree to the horizontal, right? So this is the angle 30 degree. So it becomes a question of projectile motion, right? So what kind of projectile motion? It's a normal kind of vertical projectile motion it is, but from a height, right? So normally normal projectile motion will be from this area to that area. A U-shaped kind of a path will be traversed by the projectile motion there. But this is a kind of different situation where it will go in this particular way and it will directly fall off on the ground at a distance like this, right? And this much distance is called by the name of range of the projectile, and the time it takes to cover this range is called by the name of time of flight, right? Okay, so let us try to solve this. Height is 60 meter and a speed of 40 meter per second is the velocity of projection, right? Initial velocity of projection. Now the point to remember here is that, like, we were actually talking about time of flight of normal kind of situation which you were throwing the ball vertically upwards, isn't it? You were throwing the ball vertically upwards. Now how did we get the answer for that question? We considered velocity which is vertical, right? We considered velocity which is vertical. You are throwing a ball upwards, so the only velocity it has is a vertical velocity. But if you talk about this kind of an inclined velocity, you have two components for this, isn't it? You have two components for this particular inclined kind of a velocity here, and this component is 40 cos 30 and 40 sin 30. Okay, now which of these will you use for the purpose of solving this? We are supposed to find out time of flight. In the previous questions, when you were throwing it vertically upwards, you were using the velocity which is vertical to find out the time of flight. Although in that kind of questions, you have only one velocity which is vertical. So here also we will be using the vertical velocity, vertical component of velocity for solving this to find out the time of flight. So time of flight is equal to u by g plus root of u square by g square plus 2h by g. In place of u, I will be substituting 40 sin 30. That is the vertical component, right? Okay, so what is 40 sin 30 now? Sin 30 is 1 by 2, isn't it? So this is 20 meter per second. So in place of u, I will be substituting 20 by g, 20 by 10 plus root of 20 into 20 is 400 upon 100 plus 2 into height h is 60 divided by g is 10. 2 6 are 12 plus 4 is 16. Root of 16 is 4. And there is a 2 over here. Now this is equal to 6 seconds. Okay. So the time of flight for this kind of a projectile is 6 seconds. Now if I tell you, find the range of the projectile, if that is the question that they are asking here. So we are actually now in the domain of projectile motion, isn't it? We have started with one-dimensional motion, we have eventually landed up in two-dimensional motion. If the question is to find the range, let us suppose they are asking us to find the range of the projectile. Now tell me, range means it is the horizontal distance covered by the projectile in its motion from the initial position to the final position. The horizontal distance covered by the projectile in its motion from the initial position to final position. From the initial position to final position, it is covering this much horizontal displacement or distance, right? It is covering this much distance in the horizontal direction. Eventually, this is the displacement also. So, how can I find this out? Now, I just thought of discussing this over here. See, whenever you have a projectile motion, you have two velocities. One is in the vertical direction and one is in the horizontal direction. The horizontal velocity is uniform velocity. It is a constant throughout the motion. Vertical velocity is uniformly accelerated. So 40 sine 30 is uniformly accelerated, but this is uniform motion. That means at every point of its trajectory, the horizontal component of velocity is 40 cos 30 itself. There is no doubt in that, right? So if it takes 6 seconds to reach from here to here, you can simply equate 4t cos 30 multiplied by 6. Why? Because you know distance is equal to speed into time. It is because of the horizontal velocity it is going to cover a horizontal distance. It is because of the horizontal velocity it is going to cover a horizontal distance. You require the horizontal distance. So what will you do? Distance is equal to speed into time. Why? Because velocity is uniform velocity. This is not an accelerated condition, right? So 40 multiplied by cos 30 is root 3 by 2 multiplied by 6. 2 into 3 is 6. This is 120 root 3 meters. Okay, right. Now if they are asking you the maximum height attained by the projectile, how will you find that out? For finding the maximum height attained by the projectile, if this is, you just have to consider the vertical component again. And what can you do from that? S is equal to ut plus half at square, ut minus half gt square. So S is equal to u is 40 by 2 is 20 multiplied by t is, how much is the time taken to reach over here? Time is equal to u in the vertical direction is 20 by 10. This is equal to 2 seconds. U by g. So S ut minus half into 10 into t square is 4. Right? If you solve this, you will again get the value of maximum height attained. 2 into 2 is 4. This is 20. 40 minus 20 is 20 meters. So it has to cover this much distance of 20 meters. This is the maximum height attained by the projectile. Right? So this is how you can actually crack a question whenever they are asking you a modified projectile motion like this. Okay. So the rest of the projectile motion I have discussed in separate videos. Let's go to other questions pertaining to this particular chapter that we are discussing. Now imagine a situation like this, guys. Let us suppose that, okay, now we know whenever a ball is thrown upwards, it goes up and it comes down. Right? So this is the way it can be shown. The correct way is actually it goes up and it comes down in the same straight line, isn't it? So yes, if this is the condition that you are trying to find out in this image, like if this is the condition, now let us suppose that I am talking about a condition where with a velocity u, the ball is thrown downwards, just downwards. There is no going up here. It is just thrown downwards. Here, let me tell you, if this goes up with a velocity u, if this is going up with a velocity u, what is the time of flight? Time of flight is equal to u by g plus root of u square by g square plus 2h divided by g. Now tell me if this is the height here. Now this tower is also having the same height. It is thrown down with the same velocity with which this body was thrown up. So this is very similar. But here my body is going up and then it is coming down. But here the body is directly coming down. Okay. Now how can I find a formula for this? Will this formula work out in this case also? This is what I am trying to understand by this particular method. I mean, I am trying to derive a formula for the other one also. So it goes up, it reaches over here, time taken is u by g. Okay, then it again comes down to this level, it goes up, time taken is u by g, it comes down here, when it reaches over here, again the time taken is u by g. So the total time is 2 times u by g, isn't it? 2u by g. This is the time taken by the body to reach the same level as that of the tower itself. It goes up to the topmost position u by g. It comes to the same level of the tower, again u by g, right? So that is 2u by g. Then it comes down. It takes some time to come down. If you add everything, u by g plus how much time it is taking, how much ever time is taking, it is taking to reach this much, cover this much distance. If you add all the three, you are going to get this equation. So this big equation comprises of three things: the time of ascent, time of descent till the level of the tower, and beyond that also. So number 1, number 2 and number 3, right? So there are 3 times which are added to actually get this equation. But what is the difference here? See, whenever a body goes up and comes down, here what is the velocity of the body here? If I am throwing a ball up with a speed u, the same speed it will be having at this position. right? The same speed it will be having at this position, right? So I can say that this particular motion of the body, which is from this position to this position, from the tower directly downwards, is just the same motion minus this part. Minus this part. If I just subtract this much part, I will get this. Why? Because the initial velocity over here is u. When it comes to here, comes to the same level of tower, its velocity is again u. So this entire motion minus the topmost part is this motion. So what will be the time of flight for this condition? Time of flight is again u by g plus root of u square divided by g square plus 2h by g minus this part. This part is u by g up, u by g down. That is 2u by g is the total time to cover this much distance. If I subtract this 2u by g, I will be getting a equation that is minus u by g plus root of u square divided by g square plus 2h divided by g. So this is the time. So that is the time of flight of a body which is directly vertically thrown downwards. And how would we get that? We could get that from this particular formula itself. So this formula is so useful that you can solve many questions with this particular formula, right? And with that we come to the end of this particular video. So I hope you could participate well in this particular discussion, and please keep on solving more questions from this chapter. And this is a kind of chapter which I have realized that every time you write a new exam, you get a new kind of a question, isn't it? So this is a bit tricky kind of a chapter. As questions become more difficult, you require more concepts to solve it, more ideas to solve those kind of questions. And this is a kind of chapter in which I have seen that this has a lot of layers to it. You feel that okay, you have mastered it, and then you go to an exam and you feel that okay, there are certain questions that I still don't know. I'm not getting the way to solve those kind of questions. And then again you master those questions, and then again you go to write an exam in the next year, and then you understand that okay, there are certain questions that still I don't know how to solve them in the best possible way. So my job was to make certain types of questions that I have seen during my preparation time easier in this particular chapter. We'll continue solving questions in this, and keep watching my channel. I will be putting more videos on this particular topic with new questions. With that, I come to the end of this video. Please like, share and subscribe to my channel. Click the bell icon to receive notification whenever I upload a new video on YouTube. Thank you.